Now let us look at certain set operations and relations. That is the pros of set operations in this particular section. And on an important point before we go into this particular topic is that uh, when we did operations in the set theory, we usually took a single element, that's A or B or X or Y, and did the proof. And because in relations we are dealing with ordered pairs, here the element as such would be a pair, that is A B or X Y. So and we'll be doing a lot of this proofs and set operations of relations both in the sample problem section as well as in the question bank. So let us start with a relatively simple case, that is A times B union C is equal to A times B union A times C. Now, as I already told, we are taking an arbitrary ordered pair instead of an element, and suppose the ordered pair is AB. And in such cases, as I already mentioned in a previous video, we try to derive two subsets, in the sense that we know that if A is set A is a subset of set B, and if it's also a subset in the other way, and that is if set B is also a subset of set A, then we are dealing with equal set. So that's exactly what we are trying to do here. And so AB is an element of A times B union C. Now B union C simply means that so you're dealing with an ordered pair. So the first step is we are separating out the elements, that is A is an element of set A and B is an element of set B union set C. Now we are separating out the second part, that if B is a union of if B is an if element B is an B is belonging to B union C, it simply means that it should be belonging to either set B or set C. So that's what we are doing in the next step, that is A is an element of set A and B is an element of set B, or B is an element of set C. Now the next step is A is an element of set A and B is an element of set B. And as you can see, the common point coming here is A being an element of set A. So or A is an element of set A and B is an element of set C. Now what does it mean? It simply means that if A is an element of set A and B is an element of set B, it simply means that that ordered pair ought to be a product of the Cartesian operation between those two sets. So that's this next step, that is the ordered pair AB is an element of A times B, or that's also possible in the other case, that's ordered pair AB is an element of the Cartesian product of sets A and C, which brings us to the point that the ordered pair is an element of the Cartesian product of A times B union the Cartesian product of A times C, which simply means that A times B union C is a subset of A times B, that is the Cartesian product of set A with set B union the Cartesian product of set A with set C. Now we know that we have to prove the reverse subset. We have to come up with the proof for a reverse subset so that we can equate the both sides of this particular relation. So that's what we are doing in the next step, that is to avoid confusion, we are taking another ordered pair, that is we are putting different letters for the next ordered pair, that is X and Y. So if X and Y are the elements of the ordered pair and it's an element of A times B union A times C, it simply means that it is either belonging to A times B or belonging to A times C. That's the next step. That is the ordered pair X Y is an element of Cartesian product of sets A and B, or uh, it's an element of the Cartesian product of sets A and C. Now we are separating out the elements, that is X is an element of A and Y is an element of set B, or X is an element of A and Y is an element of set C. Which brings us to the point that X is an element of set A and Y is an element of set B, or Y is an element of set C. Now, as we already know, when this or is put in, it simply means that we are indicating a union. So X is an element of set A and Y is an element of B union C, which simply means that the ordered pair XY is an element of A times set B union set C. So that means the Cartesian product of sets A and B union the Cartesian products of sets A and C is a subset of A times B union C. And coming to the conclusion, as I already told, if a particular set is a subset of another set, and that second set is also a subset of the first set, it simply means that we are dealing with the equal set. So that's how the equal property is explained or proved. So from the particular relations 1 and 2, we come to the conclusion that A times B union C equal to the Cartesian product of set A times set B union set A times set C. Thank you.